Okay, so somebody asked me about p-series, and this was covered in class, but I'm going to just do the same thing over again as a separate video. So the question about what happens, is this going to converge or diverge? So it is equal to either infinity or something, like something that's not equal to infinity. What does it look like? Well, if this is the curve 1 over x, and this is the point 1, 1, it's the area under the curve. Now, I want you to consider in this particular instance, the symmetry, right? This curve, 1 over x, is symmetric through the line y equals x. So this little green shaded peak has to equal the same thing as that red, the red tail. If these things were finite, which they're not, they're infinite, but if it were, then the integral from 1 to infinity is going to equal to the integral from 0 to 1 minus that little box, this little box here, right? So that's what would happen. So either they're both infinity or they both converge. It turns out they're both infinity. So let's go ahead and show that why this is the case. So standard calculus stunt, you think you can use the power rule, you can't. This is the special case, and you're going to get natural log of x. But let's pretend that you forgot that. If we try to increase that exponent and then divide by the new exponent, this is bogus. You see that and you realize that's bogus, and you're saying, oh yeah, I remember, that was the one that's natural log of x. Okay. Well, what's the natural log of infinity? Well, that's infinity. Natural log of 1 is 0, infinity minus 0 is infinity. And yeah, okay, I'm shortcutting the notation in a way which I allow you to shortcut the notation as well. So the take home from all this is this guy does not go to something. This guy definitely diverges. And because of this specific one is special, that also 0 to 1 also diverges. Okay? That is more generally stated this way, where p is equal to 1. That exponent is 1. So what happens when that exponent is something else? Okay, so what ends up happening is you can think of this 1 over x as being right over here. So this is your reference point. And now what happens if we have another curve 1 over x squared? Where does 1 over x squared live versus 1 over x? All these curves, all the p-series, they're going to go through the point 1, 1. But when x is greater than 1, 1 over x squared is smaller than 1 over x. So you're going to cut smaller. However, on the other side of this curve, it's going to be the opposite effect. Okay, so when x is smaller than 1, x is between 0 and 1, when you square something, it gets smaller. So when you take the reciprocal, it gets bigger. So obviously, by the comparison test, if the integral from 0 to 1, 1 over x diverges, and then this red thing is larger, okay, then obviously this must also be infinity. Okay? So that much we know. And so all these guys from, let's see, 0 to 1, 1 over x to the p dx, if p is greater than or equal to 1, this diverges. Okay, so this is a fact. We just figured this out. Now, what happens on the other half of this curve? Well, the other half, the 1 to infinity piece. Okay, so we cannot use the comparison test. all we know is it's less than something that's infinite, so the comparison test is useless. So let's go ahead and just take x to the negative 2 and see what happens to it. Okay, so we're going to increase the exponent, divide by the new exponent. Okay, and what does that look like? 1 over x. All right, so then we have minus 1 over infinity plus 1 over 1. 1 over infinity is 0, and that's what we get. And I'm not going to go through this example for all different values of p clearly, but it turns out this guy will converge for p, any p that's greater than 1, but not equal to 1, because the equal to 1 case is different. Okay? Yep. We already talked about it diverges if p equals 1. Okay? So that takes care of half of the combinations you need to worry about. Let's see. Right, so what about things like 1 over square root of x? Okay, so now let's look at 1 over x versus 1 over square root of x. Well, when you take the square root of x for x greater than 1, it makes x smaller, which makes the reciprocal larger. Then you can use the comparison test out here. Sorry. So from 1 to infinity, if p is, in this case, let's say p is a half, or any of these blue ones, p is going to be smaller than 1. P is smaller than, or in this case, equal to 1. We know this is diverges. Okay, so there's a little fact. And then what about what happens on the other side over here? On that side, you can't use the comparison test because all you know is that you're smaller than infinity, so it doesn't really help you any. If you figured out the symmetries, you figured out what's going on, because you see this curve right here is really analogous to this curve. I forget which one I just highlighted. I think this one. This curve and this curve are very similar. Okay? They're just flipped around the y equals x axis. But let's go ahead and just do it out. Let's pretend we didn't notice that. What we want to know is 0 to 1, 1 over, let's say, square root of x dx, and let's see why, what's going to happen to that. And let's use it as sort of like a test case, and it's actually everything between 0 and 1 is going to behave the same way. Okay, so this is the same as saying x to the minus 1/2. Let's go ahead and use the power rule, increase the power by 1, divide by the new exponent, and that's going to be 2. Okay, so it turns out 1 over x to the p dx is going to converge when p is between 0 and 1. I guess I should have put a 0 over on this one too. There you go. Okay, and then I'm going to just get rid of all this explanation. So you can just see, you know, the 4 facts. And again, just think of it as everything revolves around this curve here, this 1 over x curve. All right? You just know that other than the 1 over x curve, all the other p series is going to converge on one side and diverge on the other side. So it kind of like tips around. This is kind of the balance point. And everything else is going to, one of these asymptotes is going to have a convergent amount of area trapped between the curve and the axis, and the other one's going to have an infinite amount of area trapped between the curve and the axis. Okay? So if you have trouble remembering these, then you can just put these on your crib sheet, and hopefully that will help.